Good evening, students. Welcome back to Sunain Sir's online classes. In this video, I am going to explain you Human Eye and Colorful World chapter part 4. In part 4, I am going to explain completely about scattering. Scattering is a very complex phenomenon. In order to explain this scattering, I would like to give you a small example. That is, take a iron chair and place it under the sun for nearly 2 or 3 hours. After 2 or 3 hours, if you observe, it will if you see, it will absorb lot of heat energy. It will absorb lot of heat and light energy. All the light energy which is coming from the sun, that iron chair will absorb, and after that 2 or 3 hours, bring that iron chair inside the room and keep it in the room. Now if you see, after half an hour the room becomes hot, because whatever the light energy is absorbed by the chair, that chair will re-emit that light energy which is absorbed when it is kept outside. That is nothing but scattering of the light. Scattering is nothing but the process of re-emitting absorbed light energy in all directions is called scattering. When any object or medium is exposed to light, the particles of the medium absorb that light energy. After absorbing light energy, they start emitting some part of it in all directions. This process of emitting, re-emitting absorbed light energy in all directions is called scattering. Now, will a object or medium will scatter all types of light? No, it will not scatter. Any medium or any object will not scatter all types of light. The medium will scatter only some particular wavelength of the light. That is, in order to scatter a light, the important condition is size of the particles of the medium should be nearly equal to wavelength of the light. It means only certain objects or certain medium will scatter only certain types of light. For example, nitrogen and oxygen molecules will scatter only blue color light, as their size is nearly equal to wavelength of the blue color. It means the very important condition for scattering of light is size of the particles of the medium should be nearly equal to wavelength of the light. Since here nitrogen and oxygen molecules will have size, their size will be nearly equal to wavelength of blue color, they will scatter blue color. Hence, when white light passes through the medium of nitrogen and oxygen molecules, it will appear blue. That medium will appear blue because these nitrogen and oxygen molecules, they will scatter blue color light. It means they will absorb blue color light, and in turn they will re-emit that absorbed blue color light, and as a result that medium will appear blue. Now let us see some of the applications of scattering. First important application is why sky appears blue. Answer for this is, we know that atmosphere contains 78% of nitrogen and 21% of oxygen. If you combine these two, it means around 99% of atmosphere contains nitrogen and oxygen molecules. Remaining 1% is of carbon dioxide, sulfur dioxide, helium, etc. Remaining 1% is remaining gases. So size of these nitrogen and oxygen molecules is nearly equal to blue color, wavelength of the blue color. Hence, when they scatter blue light, sky appears blue. Next, why sky appears white? The reason for this is, on a hot day, due to high temperatures, rate of evaporation of water from seas and oceans will be very high. We know that when temperature is very high, rate of evaporation also increases. So this leads to abundant presence of water molecules in atmosphere, and size of these water molecules is higher than nitrogen and oxygen molecules. Hence, these water molecules scatter colors of all frequencies. It means they will scatter colors of all wavelengths VibGR. All the colors, these water molecules will scatter all the colors, and in turn they will re-emit all the colors. Scattering means they will absorb all the colors, and in turn these water molecules, they will re-emit all the colors. So hence all these colors will combine and appear as white. That is why on a hot day sky appears white. Now, why sky appears red? During sunshine and sunset. During sunshine and sunset, sunlight has to travel more distance to reach our eye. So during this time, sunlight is traveling large distance, and because of this large distance, there are more chances of all colors to scatter to a great extent, because sunlight is traveling large distance. While traveling large distance, there are more chances of all colors to scatter to a great extent, except red color, because red color has high wavelength. Because of high wavelength, red color will scatter least in our atmosphere. Hence, all colors will scatter more and vanish before they reach our eye, except red color. Red color will be scattered least. That is why only red color reaches our eye, hence sky appears red. Now let us see why sun appears white during noon. During noon, sun will be directly above us. Distance traveled by the sun to reach our eye is less. So when there is less distance, all the colors will scatter, even red color also will scatter. So combination of all these colors will make sun appear white. Next, one of the very important application is, this question is also asked many times, that is, why fire alarms and danger lights are made of red color. Why they are made of red color? Answer is, we know that because of its higher wavelength, red color will undergo least scattering by the particles of any medium. In case of occurrence of any accident or fire, it means in case of any fire accident or any other accident in industries, that industry will be completely filled with gaseous medium. One has to switch on danger lights and fire alarms. In such cases, when completely filled with gaseous medium, when there is accident in the industry, that industry will be completely filled with gaseous medium. Then one has to switch on danger lights and fire alarms such that everyone can easily identify the accident area, and to make the precautionary measures, it means to make the people avoid coming there, and to make any precautionary measures, one has to switch on danger lights and fire alarms to take precautionary measures. Now, so when these lights are switched on, they emit red color light, and this red color light will travel long distance without undergoing scattering by medium, by particles of any medium. That is why these danger lights and fire alarms are made up of red color, such a way that they will emit red color, because in case of any accidents, this red color has to travel long distance in order to ensure that everyone knows the accident area. And also red color travels fast compared to other colors as it has longest wavelength. We know that V is equal to frequency into wavelength. So when wavelength increases, then velocity also increases, because frequency remains constant. So as a result, velocity of red color will be very high because of its high wavelength. Thank you for watching the video.